Hi everyone, this is Mrs. J. Today we're going to learn how to simplify rational expressions. Before we get started, I have a quick warm-up for you guys, so please pause the video and give these a try and hit play when you're ready to check your answers. Alright, go ahead and check. So for part A, you can factor it with difference of two squares. For part B, there's simply a GCF of 2x, so you have these two factors. For part C, we can use that grouping method. So here are your final factors, and for part D, this is difference of two cubes. So here's the formula for that, and resulting in these factors. So if you need a review on any of these methods, make sure to go back and watch my videos on factoring, because everything that we do for the rest of this chapter is going to be really heavy on factoring. So this is you really need to make sure that you are up to date on these skills. Okay, so a rational expression is a ratio of two polynomials. It's essentially a fancy way of saying it's an expression that is in the form of a fraction. So there is one really important thing to remember about fractions. We have to remember that the denominator of a fraction can never, ever equal 0. So we're going to be taking this into account today because many of the expressions that we'll be working with actually have excluded values, because we want to make sure our denominator is never equal to 0. All right, so we're going to start by learning how to identify excluded values from a rational expression. So these excluded values are going to happen whenever our denominator is equal to 0. So we're essentially going to be finding the zeros of our denominator, and those are going to be the values that are excluded. So let's look at part A. So here we can see our expression is 2 over x times x minus 5. So here our denominator is already factored for us. So again, we're looking for times when our denominator is 0, so values that x cannot be. So I like to essentially take each factor and essentially do zero product property, but instead of saying x equals 0, we would say x cannot equal 0 because it's an excluded value. And we'll say x minus 5 cannot equal 0. We'll solve it like a normal equation. X cannot equal 5. So we have two excluded values. X cannot equal 0 or 5, because those are the two times when our denominator would be 0. So essentially you take any factor in your denominator and you say that it cannot equal 0. All right, let's look at part B. We have negative 2 over xy squared. So one of our factors is x, so we know that x cannot equal 0, and we know that y squared cannot equal 0. So if we solve, that would just mean that y cannot equal 0. So here our two excluded values are x cannot equal 0 and y cannot equal 0. And again, those are simply the two times that would turn our denominator to 0. All right, so now let's look at part C. We have 2x plus 1 over x squared plus 4x minus 5. So again, we're trying to find times when our denominator would be equal to 0. So to do that, we actually need to factor the denominator. So this is going to be a really common first step we take when we're simplifying as well. So let's factor the denominator really quick. So it multiplies to make negative 5 and adds to make 4, be 5 and negative 1. So we have 2x plus 1 over x plus 5 times x minus 1. So here we're going to take each factor separately and say that it cannot equal 0. And x minus 1 cannot equal 0. So here this gives us that x cannot equal negative 5. And this tells us that x cannot equal 1. So those are our two restrictions. So if your denominator is not already factored, you may need to do that first. But this is going to be the first step that we take with pretty much any problem where we're simplifying a rational expression. All right, so now that we know how to find our excluded values, now we can move on to simplifying. So we're going to simplify expressions just like any other fraction. We look for common factors in the numerator and denominator, and we can cancel them out. Here we just need to make sure to list any excluded values before we eliminate common factors, because just because we eliminate them doesn't mean that they don't exist. So that will always be our first step. So here I'm going to start by listing our excluded values. So this 6 we don't have to worry about because 6 is a constant number. It will never equal 0, but the x squared we do need to worry about. So we can see from this that x squared cannot equal 0, and that means that x cannot equal 0. So here's our excluded value. And now we're going to simply simplify. So we can simplify the coefficients just as we would any other fraction. And actually 30 over 6 is just 5. And then here, x to the 4th over x squared is just x squared, because we have 2 more powers of x in the numerator than we do in the denominator. So the simplified version is 5x squared with the restriction that x cannot equal 0. So this is why it's important that we list the excluded values first, because if you look at what our final result is, there's no denominator, so we wouldn't know that this is an excluded value. Okay, let's look at part B. So here we have negative 5 minus 5x over x squared minus 2x minus 3. So here we're going to start by factoring the numerator and the denominator. We should factor anything that we can. So in the numerator, you can see that we have a GCF of negative 5, so we can factor that out. Negative 5 times 1 plus x. And then in the denominator, we can factor this using magic x. So what multiplies to make negative 3 and adds to make negative 2, that'd be negative 3 and 1. So we have x minus 3 times x plus 1. So before we start looking for common factors to cancel out, we're going to start by listing our restrictions. So we can see from this factor, since the factor is x minus 3, we know that x cannot equal positive 3. Remember, if we set this equal to 0 and added 3, we would find that x cannot equal positive 3. And this factor would tell us that x cannot equal negative 1. So these are our 2 restrictions or excluded values. And now we can look in the numerator and denominator for common factors. So here you might notice that we have 1 plus x and x plus 1. Although the order is flip-flopped, since it's addition, the order doesn't matter. So these are actually a common factor, so we can cancel them out. And what we have left is negative 5 over x minus 3. So this is our simplified expression with these 2 restrictions. And again, here's why we have to list our restrictions before we cancel out, because our final answer has no factors that would suggest that negative 1 is excluded. So you always do that step first. Okay, let's have a look at example C. So for example C, we're going to start by factoring, and we'll factor the numerator and the denominator. So for the numerator, we're going to need to use that grouping method. So we multiply our A and C values, and then we ask ourselves what multiplies to make 32 and adds to make 12. So that could be 8 and 4. So remember, these are the 2 values that we'll make using 12x. So we'll rewrite 12x as 8x plus 4. So that gives us 32x squared plus 8x plus 4x plus 1. And then we can use grouping. So here there's a common factor of 8x. Here there's a common factor of just 1. So here 8x times 4x plus 1 times 4x plus 1. And here we can group these to a single factor. So 8x plus 1 times 4x plus 1. So this is our numerator. And we're also going to need to factor our denominator, and we can use that same method. So again, we'll multiply our A and C values, and we'll ask ourselves what multiplies to make 4 and adds to make 5, so 4 and 1. So we're going to rewrite 5x as 4x plus 1x. So we have 4x squared plus 4x plus 1x plus 1. Here we have a GCF of 4x. Here we have a GCF of 1. So it leaves us with 4x times x plus 1 times x plus 1. And these will group into their own factor. So 4x plus 1 times x plus 1. So here's our denominator. So you can see already how important factoring is going to be in this lesson. So again, if any of this is still a little bit tricky for you, please go back and rewatch my old videos and get more practice with factoring. All right, so after we factor, our numerator is 8x plus 1 times 4x plus 1, and then our denominator was 4x plus 1 times x plus 1. So again, we're going to start by listing our restrictions. So again, if I take my first factor and I said that it cannot equal 0, this would give us the restriction that x cannot equal negative 1/4, because I would subtract 1 and divide by 4. And this factor tells us that x cannot equal negative 1. So those are the two excluded values. And now we can look for common factors. So we actually see a common factor of 4x plus 1. So our simplified rational expression is 8x plus 1 over x plus 1. And again, the restrictions or the excluded values, these are part of our answer, so we need to make sure they are listed. Okay, let's look at this last example D together. So again, we are going to factor first. So this is difference of two squares. So in our numerator, our A value would be x squared, and our B value would be 9. So we can factor it into x squared plus 9 times x squared minus 9. And then from here, we can actually factor this a little bit more. We can actually do difference of two squares again. So our A value is x, and our B value is 3. So this leaves us with x squared plus 9, which remember there's no such thing as sum of two squares, times x plus 3 times x minus 3, all over x squared plus 9. So here, if we try to list our restrictions, so remember we take whatever factor we see in the denominator, and we would say it cannot equal 0. So that means that x squared cannot equal negative 9. And here, well, there's no way that a number squared could equal a negative number. So here we would take the plus or minus square root of both sides. We don't want imaginary numbers for excluded values. So since here, there's no number that would make our denominator 0, there's actually no excluded values. Okay, so now that we've made a note of that, now we can look for common factors, which we can see right here. We have common factors of x squared plus 9. So all we have left is x plus 3 times x minus 3. So that's the factored form. And usually if we don't have any, usually for our numerator at least, we will multiply it out for our final answer. So our final answer goes back to x squared minus 9. We still need to factor it in this step just to make sure there's no common factors, but this will be our final answer. All right, so again, factor if necessary, list your excluded values, and then you can cancel out common factors to simplify. Okay, so I have 3 problems for you to try on your own. So please pause the video and give them a shot. And then when you're ready, you can hit play to check your answers. All right, so go ahead and check your work. For part A, our only restriction is that x cannot equal 0. And then if you simplify, you should end up with -2 over 3x to the 4th. So you can see we have 4 more powers of x in the denominator than the numerator, which is why our answer is over x to the 4th. For part B, the numerator can be factored using difference of 2 cubes. The denominator is simply a trinomial that can be factored. So from here, we see that x cannot equal +7 or +1. And then after you cancel out your common factor, you're left with this rational expression. And then for part C or D, it's mislabeled, but that's okay. You can factor the numerator using grouping. So that should be 2x plus 3 times x minus 4. And then you can factor the denominator using difference of 2 squares. So 2x plus 3 times 2x minus 3. So this tells us that x cannot equal -3/2 or +3/2. Those are our excluded values. And then you can cancel out the common factors, leaving you with x minus 4 over 2x minus 3. So I know it's a little bit of work to get everything factored, but it's really important, again, that you always factor first because it will help you list your restrictions, and then it will also help you to simplify. All right, so now that we know how to simplify rational expressions, we're going to do just a quick introduction to adding and subtracting rational expressions. So a quick reminder, whenever we're adding or subtracting fractions, the rule is that you must have the same denominator. And if you don't have the same denominator, you have to find that least common denominator, and you have to change maybe one or both of your fractions until the denominators are the same. So today we're just going to do a quick review on how to find a least common denominator. So again, here we're going to be looking at 2 pairs of rational expressions, and we're going to decide what the least common denominator is. This will lead into our next lesson where we'll actually be adding them up. But here is a good hint. We're always going to factor first. So let's look at part A. So here we have 2x over 3x plus 27 and -5x over 2x minus 16. So we're going to start by factoring both. So the first one is 2x over, this has a GCF of 3, so 3 times x plus 9. And then our second expression is -5x. These two terms have a GCF of 2, so 2 times x minus 8. Now to list out an LCD, we're going to be looking at any factor that's in the denominator, and we're going to make sure that's included as part of our LCD. So the first thing we can look at are the constants, or the just the numbers. So we have 3 and 2. So the least common factor of 3 and 2 would be 6. So that's going to be part of our LCD, right? Because 6 works for 3 and it also works for 2. And then the next factor that we see that must be included is x plus 9, so I'll list that. And then the next factor we see is x minus 8. So we're essentially going to be trying to list out or include any potential factors that we see in our denominator. So this would be our least common denominator of these two expressions. Okay, let's look at part B. So here we are only looking at the denominators, but when we factor, we might as well factor everything. So for that first numerator, we can use difference of 2 squares. Our denominator, we can use GCF. So we can factor out 7, and then we have x minus 6. And for our second one, our numerator, we can factor out 7, so times x plus 2. And then in our denominator, there's a common factor of 11. So x minus 6. So again, here we're just looking for the least common denominator. So the first thing we can look at, again, is those constants. So we have 7 and 11. So the LCD of 7 and 11 would be 77. And then the next factor I see is x minus 6. So since x minus 6 has already been included, it actually works for both, so we only need to list it once. So our LCD is 77 times x minus 6. All right, let's look at example C. So again, let's start by factoring. So in our numerator here, we have 2 times x plus 3 with GCF. And then in our denominator, we could use magic x. We would get x plus 5 times x plus 2, what multiplies to make 10 and adds to make 7. And here we would have 7 times x plus 3. And then in our denominator, we have a GCF of 21, so it becomes 21 times x plus 2. So this is why we should always factor the numerator and denominator, because in this case, we can actually simplify this expression. So we should do that because it will make our LCD a little bit easier as well. So if I have 7 and 21, this will cancel out and this will actually just become a 3. So our denominator is 3 times x plus 2. So for the LCD of this pair, again, the only constant I see is 3. So we have that. And then I see x plus 5, which will include. And we have x plus 2 on both sides, so we only need to include it once. So there's our LCD. And last, example D. This one, everything's been factored for us already. So we have 1 over 2x to the 6 times x plus 1, and then 1 over 6x times x plus 1 squared. So let's start with the two constants. So we have 2 and 6. So the least common denominator, or the least common factor of 2 and 6 would be 6. So 6 is divisible by 6, 6 is divisible by 2. It works for both. Then we need to look at the powers of x. So for the powers of x, we have x to the 6th and x. So we have to make sure that our least common denominator works for both. So essentially, it's going to always be the higher power. So in this case, it's going to be x to the 6th, because x to the 6th works for this term on the left and the term on the right. If we just did x, that wouldn't be enough powers of x to accommodate the left side. So it has to be x to the 6th, but that does take care of both. And then the next thing we see is x plus 1. So on the left side, we only have 1 power, but on the right side, we have 2 powers. So in our LCD, we actually do have to include x plus 1 squared, because again, it has to work for both, and this power is squared. So the LCD of those two terms would be 6x to the 6th times x plus 1 squared. All right, so here's our last example of the video. I'm gonna ask you to pause the video and see if you can find the LCD of these two pairs of rational expressions. All right, go ahead and check your work. So for part A, after you factor that first term, you get 3x times x minus 3 in the denominator. Our denominator here is 5x. So the LCD of 3 and 5 is 15. Here we have a single power of x on each side, so x works, and then we still have to list x minus 3, so all of the factors are included. And then in part B, if you factor the first one, we actually have a common factor of x minus 2 that cancels out, so you can do that. And then you do need to factor your denominator on the right side. So what you have left over are the factors x minus 4. There's just a single power on each side, so we only need to include it once, and then we still need to include x minus 5. All right, so there's your little recap or an introduction on how to find the LCD of rational expressions, which we will be using in the next lesson. That's all for today's video. Thank you so much for watching.